Good evening and welcome back to the session. The 1 week long sessions we are discussing about the business analytics concepts and you have to come here. We've been discussing about the introduction to business analytics. Then we talked about different phases of analytics. We've also tried to have a quick overview of business analytics and data analytics, the comparison between them, and we have also seen the application use cases, right? We have discussed about agriculture use case, we have talked about banking sector, credit card sector, so on and so forth. And as part of the stages, we've discussed about descriptive diagnostic analytics past and predictive analytics and prescriptive analytics, which look into the future. So we first try and understand the past and then map that past to future. Then we said, in order to implement the solutions, we have to follow certain standards. We have to follow a process. That process is called as CRISP MLQ methodology. And as part of the process, just like any process methodology or any standards, we will always start by gathering the requirements and understanding the requirements. This falls under business understanding and data understanding scenario. Here we are trying to look into the business scenario, the processes that the business follows, the various stakeholders that are getting involved in that business, right? And the various other aspects, what kind of infrastructure they are using, what level of business they are doing, etc., etc. And we discussed that we have to understand the scope and define the objective. Along with that, we also have to identify the challenges, the constraints that have to be implemented. This is what we discussed with respect to business understanding. Now, when you're trying to understand the business, you'll also be asking relevant questions to understand what are the various features the business is dealing with. Features are nothing but your various attributes. We also call them as attributes. Or in data set for terminologies, the data terminology, we also call them as columns or variables. From a business perspective, we also call them as characteristics. So we have to define the features that are relevant, identify those features in the first place, and map them. And along with this, we will also try and understand the size of the data, the various other characteristics of the data. Then, once we've identified the features, we also have to identify the sources from where we can get this data. Is this data already available? If so, we can directly go to that source and fetch the data. If it is already available, that means the data was being collected for some other purposes, not for this specific problem that we are trying to solve. So this falls under secondary source. We call this as secondary source. But if the relevant data fields are not available, then we will have to try and get that data. And for that, we have to try and devise various strategies and collect the data. This data is called as primary data because the data is being generated or collected for specific problem that we are solving. Right? So hence it's called as primary. Once the data is collected, data collection happens. Now we also have to look at the values of the features, right? So this is the feature. We define what is the feature here. But now we have data. So what does this data talk about? Does it explain the business conditions appropriately or not? That is what we have to understand. And as part of this, we do various preliminary statistical calculations, which gives us results. Those results are called as statistics. And using these results or the statistics, we try to generalize the characteristics for the entire business case, population case. So we are basically trying to do the calculation of inferential statistics. Is what we are trying to do. Now, as part of the preliminary analysis, EDA, which is also called as elementary data analysis or exploratory data analysis, we are basically trying to do simple mathematical calculations. And the first calculation that we do is explaining the characteristic of this entire data, the meaning for this entire values. So we are trying to represent all this data using a single value. This is called as first moment business decision. We call them as business moments. So the first one that we are talking about is called as first moment business decision. We call this as measures of central tendency. Okay, so this is basically called as first moment. Let me write it here. First moment business decision, which is also called as measures of central tendency. This basically is representative value for the data set. Then we talk about the second moment business decision. This is called as measures of dispersion. Measures of dispersion. Dispersion basically means spread, variation or deviation of the data from the first moment, from the representative value, because this representative value is giving the picture for the entire data set. But each value, when you check, it would be definitely not same as the value that we have defined here. So there will be some variations or deviations. The second moment is capturing that. Then we have third moment and fourth moment business decisions. This one is called as skewness, and this captures the direction of the data from the center. The skewness is the spread of the data from the center. Variation or deviation of the data from the center, which is nothing but the representative. Right here also we are doing the same, from the center. Spread of the data from the center, which is nothing but your representative value. Either this or the center. So this is direction of the spread in the data from the center. And then finally, we have the fourth moment business decision, and this is called as kurtosis. This represents the overall spread of the data from the center. Again, we talk about representative. Whether the data is very close overall, if the data seems to be very close to the center, or is it very, very, very far away from the center, is something that is measured here in the fourth moment. Now, how do we try and interpret these things? Now, if you carefully observe here, each of this data that we are talking about, right? Each of the data set that we are talking about. Yeah, which is the first movement. It speaks about the center. Okay, so if my data set is like this, I'm representing the center. That is the first movement, which basically can be explained as the value for the entire data set. But from here on, the second movement, the third movement, and the fourth movement, each of this is representing the spread in the data set only. All the three are representing the spread in the data set only. For example, if you see this heart rate, this is a visual representation of the heart rate, a human heartbeat. Now, if you are a doctor, right? A a cardiologist. Cardiologist basically means the people, the doctors who are specialized in dealing with heart-related problems. So cardiologists, when they see this report, they will be able to identify what is happening with the patient's heart. But when you are looking at this, mean, which is the first movement business decision, gives the picture for the entire heartbeat, which is collected for a certain duration. As a standard, we will collect for 1 minute. So this is our data. Collectively, we are saying that for 1 minute, the heart has to beat 72 times. That's an ideal standard, business standard. I mean, a healthy heart rate is around this. So when you look at the first movement, you will be able to understand whether the person's heart is beating at a good rate or is there any problem with the person's heart. But along with that, you need to understand the deviations in the pattern. If you see there is a specific pattern, when you try and understand these other three business movements, we will try and understand the deviation that is happening with respect to the expected behavior. Expected behavior is this, right? Going up, coming down, going up, coming down. But if you see in that pattern, some deviation is happening a little higher than the remaining beats. Only here it is up. So when you try and look into the variations or deviations or anomalies, that is when you will be able to investigate and understand what is happening in the patient's heart, which is deviation of the actual behavior. If everything is fine, you don't need to go to the doctor, right? You don't need an expert. When the things are not happening normally, when things does not happen as expected, that is when we need to get into the details. So studying the deviations is very, very important. So you have one center, but three deviation related studies. First movement, center. Second movement is talking about the average spread. Third movement talks about the direction of the spread. Fourth movement talks about overall spread with respect to the center. Now, first and second movement are very, very easier and mandatory calculations that we need to do. In the first movement, business decision, we calculate average or mean. Calculation is represented by a term called mu, or we say X bar. We pronounce it as X bar. The difference is this is the representation for the population data, which we don't have. But this is a representation. Whereas this is the representation for the sample data that we are actually having. So what we practically do is calculate this, but using this, we try to estimate a statement per parameter, this mu. And this is what we calculate. First movement. If there is a challenge, if this calculation is getting biased, that is when we have median, or if the data is something which is non-numeric, then this calculation is not possible. In such cases, we go for more. Now, as I promised, we will be looking into the mathematical calculations and implementation of these concepts on an example sample data using Python. I'll also show it in R programming language, both. So let us go into the R and Python languages. This is Python interface, and this is the R programming language interface. I'll explain in both. The first thing is we'll have to load the data set. In R, we use read underscore CSV and we say file dot choose option. Now, what is this doing is it is basically opening this pop-up. Where is this pop-up? Select file pop-up. Here, I'm going to go through a sample file. Okay, I'll just take a sample file. Yeah, this is the file education.csv. I'll load this. It contains 773 observations, that means rows, and 3 columns. What are those 3 columns? You can click on this and you will be able to see the data. You can also double click this or single click on the name. You'll get the data visualization. This is called as data viewer. Serial number, the first column is serial number, and in total we have 773 values. Student number 1 to student number 773. And what we have is the work experience with respect to the student who has written a GMAT exam and the respective GMAT scores. So this data set talks about students' performance in an GMAT examination, which is basically a standard examination that we have in the in India for enabling ourselves to become eligible to have higher education, master programs. So performance of the students is captured here along with students having some prior work experience. So we're recording this data. The same thing can be loaded in Python as well. And in Python, I'll import the library called pandas. And using that library, I'm calling a function called read underscore CSV, and we have to give the location of the file. This gives us the data set. I'll click on the name here and you'll be able to see this. So same thing, the only difference is index starts from 0 here, whereas in R, the index starts from 1. The data set, if you study, it is the same 3 columns here or there. It's the same 3 columns that you see. 773 rows and 3 columns. That's what you see here, the size. Now, what we're trying to do is the calculation of the first moment business decision on one column at a time. EDA talks about the approach of EDA is always take one variable and try to demystify, understand that one thing. Then we can go for combining 2 columns and then trying to understand the meaning of it. Then multiple variables. This is also called as univariate analysis. Univariate analysis. So let's take one column, either work experience or GMAT. So in order to represent the column, the specific column in R, we have to use the data frame name, the table name, and then use $ symbol. I'm saying the last one, let's say GMAT. So what is the average performance of the students in this year's GMAT entrance exam? In order to know this, the functions, these programming languages are super duper easy. The concepts are already available on the YouTube videos. I've already been stressing upon this. Please go through the YouTube videos in order to learn the concepts much in an easier manner. So I'll go to playlists, and there's a bunch of playlists that you can do. This is free Python programming videos. Go through it, learn the programming language. You'll have fun when doing these programming languages, R and Python programming languages. We also have R programming language, a full-blown videos also. If I search somewhere bottom, you'll be able to see that. Let me show you. Yeah, Python programming course, R programming course, you can see, right? So there are these videos which will help you to learn things, the basics of R programming and Python programming concepts, right? Using those concepts, you can start building your own programs. So try and go through this YouTube channel to learn the foundational concepts of R and Python. So we have loaded the data set. Now coming to accessing the data set, as I said, it is the table name, dollar, column name. When I click on that, you can see it gives me the list of all the values in that particular column. This square bracket representation is the row ID. It's just a sequence number. All right. Then I can also refer to work experience on the same number, like this. Now, what we're trying to achieve is EDA, friends, here. So if I want to do the EDA, which is mean to start with the first movement business decision, measures of central tendency, it is the sum of the values divided by total. So I'm going to use very simple English terminologies. I'll say sum of the data, and this is the total. But I'm not interested in sum. I'm trying to talk about average, mean. All you do is replace that sum, put mean, and within the brackets represent what data you want to do the calculations. That's all. Very, very simple. If I want to do the same calculation for, let's say, work experience, then in place of GMAT, I'll replace that and put work experience. Very, very simple, isn't it? So we are loading the data. You'll say file.choose, which gives you a pop-up. Open that file, navigate to the location, select the file and load the file like this. Once it is loaded, the functions are super easy. Refer to the column, apply the function. If I want to calculate median, then replace the function mean with median, English words. This gives me the median. Now, in our programming language, we don't have mode. Mode, by definition, is the value which is repeated maximum number of times, which is occurring maximum number of times. Though there is a function called mode, it does not talk about this definition. It does not return the value which is defined by this mode definition, but rather it talks about whether the data is numeric or not, right? Mode of the data. Now, what we can do is we can write a custom function, your own custom function, which can return the value that you intend to. So I'm passing the data here. When we call the function, I'll pass the data. So in this custom function, we are passing the data here. And once the data is captured, we are doing a function called table. Table will return the count for each value. And then we will say max of that count. That would be the outcome for your mode value, which is repeated maximum number of times. So if I say mode, this is the custom function, right? Mode, I'm giving that name, and in place of X, I'm passing this data. Now, when you do that, it gives you 710 as the mode, and it is repeated 178 times. What we are using is this function to capture the details of which value is repeated how many times. So you can directly say table of this data and you will get the breakup. So in the data set, GMAT data set, if I click here, in the GMAT, you have 700, 640, 740, right? These marks. So the range of the values are starting from 600 to 780, and you can see 600 is repeated twice, 780 is repeated twice, and if you look at all these different marks, 178 times the value 710 is repeated. That means those many students have secured 710 marks out of 773 students. So this is the value which is repeated maximum number of times. So we're returning that as more. We can also say max, which basically talks about the row number 710, right? That's the value in this 710. If I say max, it just says that this is the result. 178 times it is repeated. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in the 12th position, what is the value I have? 710. How many times this value is repeating? 170. This is how we can try and perform measures of central tendency in R. Now coming to Python, this is the syntax. Here I'm calling this as education. In R, I called it as DF. Here I'm calling it as education. We can replace it with DF, your wish. So once the data is loaded, we'll say data dot, because if I open it, here work experience and GMAT. In R, we use dollar symbol. Here we use dot symbol. And then you'll say dot function, mean, median, mode. Very simple. This is mean, this is median, this is mode. If I want the GMAT scores, then I'll simply remove the work experience and I place GMAT in that position, and this gives us the GMAT. Right? You can see the calculations are same. 711.1643. So that's exactly what you're getting. It's rounding off in R. Here we are having more decimals. That's the only difference. Median is 710. Here also median is 710. Mode is also 710. Here also you get mode as cert. Likewise, we can also calculate measures of dispersion. This time I will execute it in Python first. You will say GMAT, right? The code is given as work experience. You can change your wish. I'll say GMAT work experience. It gives me 860. If I say standard deviation, that is another calculation. This is the, on an average, deviation of the data from 711 marks. That's overall, all the students considered, there is a deviation in the marks by the students when we are using this as a representation, 711 as representation. You can also calculate the max. If I say GMAT, you get max value as 780, and then you can say minimum as 600. If I execute both of them, then I will get the range. That is nothing but the subtraction of this. So the beauty of these programming languages is whatever you select, only that part can also be executed. So this is about measures of dispersion. And in R, if I have to do it, same thing, variance, syntax slightly changes, as you can see. And square root of this variance is nothing but your standard deviation. Right? So either you directly pass the number or you say variance calculation, square root, or you can say standard deviation. You can see all the three are same because formula-wise standard deviation is nothing but square root of variance. And if I want to calculate a minimum, functions are same, min and max. Next, coming to the third movement and fourth movement business decision. In R, we need to have this package installed. We call it as a package. We need to install. So installing is nothing but downloading that particular software and bringing it into your computer. You just say install our packages and then load the package that you have installed. Okay, when you say load, it comes and right, gets loaded into this environment, global environment. Okay, so we are loading the library called movements. And once this is done, we will say skewness and kurtosis. Skewness is showing that it is negative. That means the spread is slightly more towards left side. So rather than, if this is the median 711, it says that this side it is a little tilted more compared to this side, like this. And then kurtosis is a positive value. So it will also talk about a scenario where it says that if this is the center, data is close to the center. Higher this number, more closer the data is. That means the data is not spread away. That's what the interpretation of kurtosis is basically telling us. If I have to do that with respect to Python, then this is the syntax. You just put a dot skew there. And for kurtosis, you put dot cut. Now, the kurtosis calculation in R and in Python are slightly different. Okay, this is work experience. I'll show you the GMAT score. You get 1.176, whereas here we get 4.151. The difference is because in R, it does not calculate excessive kurtosis. It only calculates excessive kurtosis. Whereas in Python, it calculates excessive kurtosis, which is nothing but the kurtosis calculation minus 3. Okay, so you're getting that minus 3 result. That is the difference. So these are very simple 4 calculations that we will have to do for any data set that we are receiving. And this also has to be done at each column level. Okay, remember that it has to be column level. All right. Now the interesting part, we will talk about visualization. Right? This is what something I have promised that we will be discussing today. In order to understand anything, right, if you see it, it becomes better rather than hearing it, isn't it? Now, seeing does not mean the numbers that we are seeing. But if I can represent the numbers in some visual format, then understanding of the numbers from business perspective becomes much, much, much easier. So from that perspective, data should be visually represented. And there are standard visualization steps that we will have to do, or standard visualization formats that we will have to use to represent the data. Standardization, some standard forms. So let's talk about those standards. First one, I'll just try and come up with this equation to show you the visualization. This is the visualization. What exactly this visualization is doing here is taking each and every student. How many total? 773 students. And every student's marks, the GMAT scores, are plotted here on y-axis. So the maximum mark was 7. Minimum was somewhere around 600. So you see the lines that you're looking at here are varying. There are 773 students' details that are being plotted here in a very small space, right? In this space, 773 values. So it's like I have a room, right? A classroom. And in the classroom, I have 5 students. Only 5 students. So there is a lot of space. These 5 students are enjoying in their right free space in the classroom. Now what I'll do is I'll accumulate more and more people. I'll bring in 15 people into the same class. I'll now add 15 people. What happens? That place is getting occupied by more and more people. Rather than 15, I will say include 50. So this space becomes congested. Right? It becomes congested. That is exactly what is happening here. On this single space from here to here, we are accumulating 773 values. So the space is becoming congested. Right? So this is called as a bar chart. But unfortunately, because you have so many data points, it is not giving you a right interpretation. Right? So I'm basically showing this in R also. Very similar visualization that you see. It depends on the screen resolution, right? So it gets expanded, compressed. But ultimately, what you're seeing is a complete black picture because it is even smaller space where we are trying to represent all the 773 values. Now, I will randomly generate a very small data set, very, very small data set. How many values are there in this data set? 5 values. I'm defining labels. I'm calling this as a character list of character, red, blue, green, black, white. And then I'm also defining the colors, same names, red, blue, green, black, and white. Now, when I say bar plot of these 5 values, what is this bar plot doing is it's taking each value on x-axis. What is the first value? First value is 10. So the magnitude of the value is represented on y-axis. The sequence is being represented on x-axis. Right? X-axis is the sequence. Y-axis is the actual one. Height. So when I say bar plot of theta, you will see that this is what you are obtaining. 10, 20, 15, 50, and 25. You can also enhance this visualization by defining the size, the width size for each bar. We call this as bar. Right? Each one is a bar. So what is the width of the bar can be defined here. And then names dot argument. Right? So we want to name them. That names are coming from X. What is X? We are defining it as a character vector with names. And on the x-axis, we are labeling X lab is nothing but x-axis label. We are going to label this as color. And similarly, we have y-axis label called purchases. How many purchasers are there in the data? And the color, the actual color, we are trying to represent that color using this definition. It's the definition. R is intelligent to understand, right? Red means red color has to be plotted and all that. When I execute this, you can see the visualization is modified with the colors. So the point that I'm trying to derive is if you have a large amount of data, then bar plot is not ideal way to represent the data. But bar plot is the default visualization technique that everyone tends to use to understand the data better. Okay, so drawback is it is not suited for large number of data points. Now, what should I do if I have large number of data points? For example, here I had 773 values incorporated on the x-axis. They are getting fitted on x-axis, right? So what can I do here? What is the problem that we are facing here? We have too many values on x-axis. That is the reason why it is not able to show meaningful visualization. So what we do is we split this. We tend to break this up. So we will try and take the total 773 values and we are trying to split them into some bins, right? Some individual buckets. So to divide that, this is the data that we have. GMAT scores are plotted here on y-axis for this bar plot. This is only the count, right, or frequency. On x-axis, we have count. So in order to break this total data, we will try and look into creating buckets for the data set that we have, which is GMAT column, right? Data which is on the columns or y-axis. When you look into the data, you'll know that the least value is 600 and the maximum value is 780. This range 600 to 780, which is nothing but 780 minus 600, divided by your number, your wish. So if I say I need, let's say 10 bins, I want to split this into 10 bins. So what I do, divide this range into 10. So this is 180 by 10, which is nothing but 18 units. That means I will get 18 individual buckets. Sorry, 10 buckets with individual bucket size as 18 units. Now, if I want to make it a little convenient to interpret, I would say rather than 10, I will split this into 9 individual buckets. That means I'll get each bucket size as 20 units. So I'll say 600 to 620, 620 to 640. So how many students out of 773 fall under this interval? How many people will fall in this interval? Likewise, we will take till 780 upper bound. This representation of the breakup of the values is called as histogram. So I'm not able to make any sense out of this visualization because the data set is large. Now, when I say histogram, it is going to split the data into the intervals. So you can see this is 600 to 620. This is 640. This is 660, 680, 720, 740, 760, and 780. Right? So 20 units width for each bin is created. Now we can easily understand the flow in the data set. There are a lot of students who are falling at the average section. Few people are there who are very, very poor performers. And I do have few people who are exceptionally well performers. Right? So this way we will be able to interpret the data using histogram. So in Python also, I will try and design my bar plot. This is what we got. But I will do histogram. This is your histogram visualization. You want to also put little colors and all that, then you can do colors. I'm putting red color. You can also define the width size. You can also define the boundaries here, right? So all those things can be done by enhancing the code. This is histogram for this. And then the last, I should say the last visualization for our discussion, which is very, very essential and very, very important, is called as box plot. Box plot is considered to be one of the visualization which gives us all the required information to understand the data. It's single visualization, everything is explained. The speciality of box plot is it also defines exceptions as outliers. It shows them. Using a benchmark, it shows them. So let me show you the box plot. All you're doing is box plot and the data set name. This is what you do. So what you're seeing here is the spread of the data 780 and somewhere here 600. So we are seeing 600, 610 and 620. These three marks are exceptional marks, right? It has a benchmark to calculate this, and using that benchmark, it identifies that these are exceptional cases. This is the median, the middlemost value of the data set. This is the 75th percentile. This is the 25th percentile. So here you should have 25% of the data. Here you should have 25%. Here you should have 25. Here you also have to have 25% of data, not the width, but percentage of the data should be more. This is the representation of box plot. The box plot can also be represented horizontally like this. So in the box plot, what happens is it tries to break up numeric data. It works on numeric data. So it takes the numeric data and splits this into 4 parts, equal size. 4 splits, equal size. This is Q2. Median, we call it as median. So once you have the data set, you'll be able to identify the middlemost value of the data set, 50th percentile. Or median, we have seen the calculation of median in R and Python, right? How we get that. Now, from this center point, we will take 25% on either side. And this becomes your 25th percentile, which is also represented as Q1, and this becomes Q3, which is 75th percentile. Right, so 25th percentile and 75th percentile. And from here, you'll have another 25%. Here also, you'll have another 25%. So ideally, each section has 25% of data. Depending on the spread in the data, the shape will be taken. And we will also have boundaries. There are different ways to calculate boundaries. Now, what the standard that is followed is from Q1 and from Q3. The exception could be on lower side or on upper side, right? So it identifies the size of this box portion. We call this as IQR. Let's say this is 10 units, assume. So we take 1.5 times of this. That means 15 units will be there. From Q1, we'll take 1.5 times of IQR. That becomes the boundary. Same thing we do it here also. 1.5 times of IQR is taken here. This becomes the upper bound. So this is the lower limit. This is the upper. Now, any data point from the calculations, if it is observed to be outside this, right, like 620, 610, 600, will fall outside this boundary. Whatever the data points in your data set are falling outside the lower limit or upper limit, they are considered as exceptional cases. We call them as outliers. So the formula is Q1 minus 1.5 times of IQR. This is the lower boundary. The upper boundary is Q3 plus magnitude is increasing plus 1.5 times of. In short, we say Q plus or minus 1.5 times of IQR. This is the standard formula which is used by this visualization to give this representation of outliers. If this is clear, if not, I would recommend you to rewatch the video to understand how the outliers are calculated. This is in R. We will try and do this in horizontal manner for GMAT data. You'd simply say horizontal is equals to true. And you get this horizontal visualization. Now, what you see is like this, right? Try to have the peak of the bell curve at the center and then draw. So if you see here, the data is little more spread towards left side. Negative side, magnitude is lower, right? So hence, this is also called as negatively skewed or left skewed. And the data will be in negatives. If you remember the skewness calculation, if I go back to the skewness calculation, negative values. Okay? That's the interpretation of box plot. I'll do the same thing in Python. But this time I'm using an empty canvas to start with. plt.figure will give us this empty space. Even if you don't have this, that's okay. Now, once this is executed, I'll say box plot. When I execute this, the box plot is shown. Slight differences are there in the visualizations when compared to your path. And here we will say vert is equal to 0. I don't want vertically, I want horizontally, right? So vert 0 means it gives you horizontal. So these are the standard visualization techniques that are used for coming up with your EDA calculations. This is what we've done. First movement, second movement, third movement, fourth movement, and graphical representation. We have discussed about univariate visualization, but look at this. There are so many different visualizations that you can try out. We have done bar plot. I have shown you histogram, and I also have shown you the box plot, which is also called as box and whisker plot. And the speciality about this is it visually shows the exceptional cases, outliers. So it has a mechanism to quantify the outliers. We can further drill down and analyze each and every column using different visualizations. Each visualization will tell you a different story. And then after that, we can take bivariate visualization technique. That means all the visualization techniques, the 3 visualization techniques that we discussed, bar plot, histogram, and the box plot, are the techniques which work with one variable only. In our case, this one variable was GMAT data. But bivariate visualization will talk about having 2 variables, x-axis one variable, y-axis one variable. And this data is spread like this. So x is some value, y is some value, right? So when you map it, you get this data. Likewise, you'll have different data points that you are plotting on x and y space. This is called as scatter. And so on and so forth. There are many other techniques that we will actually have to study in order to make sense out of the data set. But as you can see, we will start with one column at a time, and then we will combine 2 columns. Then after that, we will combine all the columns together and perform our analysis. Now, the interesting point is the business analytics, thanks to these programming languages and thanks to a lot of research that is happening and thanks to the involvement of various domains showing interest into the data analytics and business analytics approaches, because ultimately as a business analyst, you'll have to include other team members in order to gain their knowledge on the data, right? So technical teams also come into the picture. Thanks to their interest, the entire process that we discussed is automated now. We are having libraries which can automate things. All right, this is called as auto EDA. That means I have a data set. Let's say I have 10 columns. Now, if I have to perform EDA, that is univariate analysis on this data set, then I'll have to repeat each step 10 times. Right? For each column, we're going to redo the same steps. First movement, second movement, third movement, fourth movement, and visualization. Rather than that, what you can do is use this auto EDA functions codes and use that one line code function, pass the data, and this is automatically doing the calculations 10 times. You don't have to write the 10 lines of code. So we are trying to make automation because EDA is the process which is going to take up a significant amount of time. Huge amount of time goes into this only. Unless until you understand the data in line with the business standards or business requirements, you will not be able to perform any analysis. These examples that you are seeing are Python examples, right? Python code examples. These are all libraries which will help you to automate the pre-processing, EDA steps. Very, very simple steps. So if I have 10 feeds, whatever the code that we have seen here, right, this code, which is being run on GMAT, I'll have to repeat that for the work experience also. Just like the same thing, but you're repeating. So this entire file will be repeated for all the columns 10 different times. That becomes kind of a laborious job. You're going to unnecessarily repeat the same steps, right? Humanly, you are much smarter than that. That is where people started building these automation templates. So that 10 repetitions are taken care. Internally, they are taken care, and you'll only get a report. And that report will also be on HTML, not in the private programming language level, but you will get a web browser open, and there on the web browser, you will see these values. For example, I'll just copy this code and show you. It's not copied. If it doesn't copy, we will type it. That's okay. Okay, this is the first command, which is not required. You can basically hide that. And this is the logic that we are doing. So I'll import this library. This is not designed, not defined. Okay. So I'm executing this suite with, and then here I'll say education, because my dataset name is not data, the dataset name is education. All I do is I'll execute this, and internally it is doing the calculation. See, I have not done anything, I just executed that one. And when you say show HTML, it gives you the report. So it does the calculations for serial number, which is not required, but it's still doing it. Work experience and G. If you look at this, on the GMAT, we have done, right, identified maximum, median, minimum, average. Then we talked about IQR, standard deviation, variance, kurtosis, skewness, sum, histogram. Right, if I click on that and if I scroll down here, it gives you the histogram, smallest values, largest values. So a lot of additional calculations are automatically done, not just for this data, but for this work experience also it is. So try and learn how do you automate certain things which are repeated, right? That is where we are tending to move. And thanks to these programming languages, these things are already solved. Okay, so yeah, you have all the details that are required for you to learn these things on the learning resources platform. This is the mind map, which you might want to refer to for your preparation purpose. And I've already shown, right, not just this, but you also have the other mind maps. This is for Python programming mind map. This is the Python programming fundamentals. It talks about conditional statements, loops, right from history. It goes into all the steps in order. Right, in clockwise, you have to try and look in. You can also see the mind map for R programming. Right, so this is basically how we have to prepare as well. It's easier this way. All right. So friends, I hope you have enjoyed the sessions, business analytics sessions. This is an introduction to business analytics sessions. Very, very fundamental concepts is something that we have discussed, and these are mandatory concepts that you should be familiar with. So I hope you have enjoyed the sessions. I would definitely like you people to leave comments. And yeah, attendance link is shared. Please mark your attendance. Thank you so much, friends. Keep in touch, stay in touch for further next set of videos to be conducted on YouTube Live. I'll see you on YouTube channel very soon once the schedule is defined, and you can get the notifications by clicking on the subscribe button. So subscribe to the channel and you'll get all the notifications. I'll see you soon, friends. Thank you so much for attending, and thank you so much for having the patience to listening me out. And good night, everyone.